I'm going to discuss uh, basically we are having the bitwise operators like first is the this we are calling a or, second is this sign is for the XOR, this is left shift, this is the right shift, these are the this is the AND operator. So basically we have this, and one more is we can say the not operator. So basically the purpose of this video the purpose of making this tutorial is to aware you all about these bitwise operators, and basically how we can use this bitwise operator and how it is going to help us in the during the or the interview process. So if you are from the embedded if you are embedded software if you are have like a embedded developer, then definitely the interviewer will ask the question from the bitwise operator, and the few questions are like in the bitwise operator are like divisible by 2. They may ask like divisible by 2 or divisible by 4, and second like multiplication, third is division, fourth addition, subtraction. Basically people ask these questions in the interview process during the interview, technical interview. So, but these are the very, when you will solve the problem on the divisible by 2 or 4, multiplication, division, addition, subtraction, by the help of the bitwise operator, you will enjoy while doing the problem. So, let's start from one by one. So, basically, when we are saying the OR gate, first we'll take the OR gate. So if we know that OR gate is a OR is gate is having the, you can say the this is the sign of OR, and basically the suppose you are having the input you are having input X and Y. So basically what it does, uh, this OR operator is is 0 0, it will be give you the 0, right? And if the 0 1, it will give 1. If it is a 1 0, then it will be appear as a 1, and if the input is both are 1, then basically it will come as a 1, the output will become 1. So basically this is the use of the OR gate. And so if you want, when you are writing the code, and if you want to XOR the two numbers, right? Suppose if I want to write the same thing in a code, then I will use int x and y, and I will put x is equal to 0 and y is equal to 1. And if I want the result, then I will use in this int result is equal to x or y. So basically, and then so basically you can do in this way to get the result. Suppose this is for this one, x is 0 and y. If you can do the same way for the 0 0 and the 1 1 also. Now, like second, so XOR operation, if you understand that, okay, how it is, that this is basically we are calling the truth table. This is the truth table. Now, if we move to the next is XOR. The next is the XOR. XOR is we are having the sign like this to represent XOR operation. So basically what it does, XOR operation, if we go with the truth table. See, actually this thing already available on many websites, right? But the purpose is that I am going to only discuss the basic, and then after we will do more the coding questions, so that basically so that we can understand the use of the bitwise operator. And the second that we will also discuss that why how the uh, bitwise operator we should use in our code, how it is creating the, how it is reducing the, you can say how it is optimizing our code if we are using the bitwise operator. Those things are also I'm going to discuss. So let's discuss one by one. Let's go with the XOR. So suppose in the XOR operation, what is the truth table is, suppose you are having the one, again we will take input x, input y, and the result. So the if you are having 0 0, the result will 0. If you are having 0 1, the result will become 1. If you are having 1 0, the result you will take 1. And if the input is 1 1, then the 0. So once then you can see the compare between the, the XOR and the OR. In case of the OR, when the input is same, when the input is same, right, then in case of XOR, here is the difference between the XOR and OR. When the input is same, suppose 0 0 or 0 1, 0 0 and 1 1, so the result will be 0. So you can say input same, then result 0. This is the difference between the OR and the XOR operation. So here now see the here the input is right 1 1, right, then it will be the 1. If input is 0 0, the here it is showing 0. But in case of the, meaning that because OR operation is doing to or the two numbers, you get two bits. So now in case of the truth table 0 0, here the numbers are like 1 1, here is like here the number is 1 and 1. So both are the same. So in case of 0, if it is 0 0 also, right? But here the concept is the both the input are same, then we will take the 0. So, but the XOR operation is widely used in the, widely used in solving the problem. Like suppose if you are having the question like find a unique number, find a unique number, questions like this, or find a missing number. Basically, these are the questions asked in the interview in the during the interview, and the and during the addition and subtraction. also addition and subtraction, where this XOR operation is used widely. So XOR operation is very important. XOR. So we should understand very clearly. We should not confuse with the XOR operation. The truth table. Always remember, if the input is the same, it will give the zero. Truth table. It will give the zero in case of the XOR operation. Now, if we move to the like um, with left shift or right shift, I will cover in both. So see, the left shift, just the funda is same. uh, if it is a left shift or right shift, the syntax is, this is the left shift, okay, and this is the right shift. So suppose, and no, okay, so first of all we have to see the syntax. So here is, we can see the syntax is, we can mention the, here is, it is a data, okay, and we have to write here number of times, okay, data number of times. So see, the syntax will be the same in case of the bitwise, in case of the, sorry, left shift and the right shift. There is no any change in the syntax. So what I mean, suppose you want to shift the one number 1 by 2 times. So first understand, if you want to shift 1 2 times, meaning that, so how it will happen. So first the number is 0 0 1, okay, so this is the 0 times, okay. Now you have to shift 2 times. How many times? 2 times, okay. So in the 1 times, what happened? All these will move 1 place, okay. So this 0 will out, so this will come here, this 0 will come here, this will come here, and at the end 1 0 will come. So this is the first times, okay. Now in second time, what happened? This will out, this 0 will come here, this 1 will be here, and this 0 will come here, and again 0 will come. So this is the second time, you can say. So now you understand. So basically what happened, when we are shifting right to left, and if there is nothing number, see here is nothing, there is no any number after the this one, right, then we will put 0 and we'll shift one by one, okay. So this is the concept. So final, if we, when we do one left shift by 2 times, then final number will 0 1 0 0. So this is the number you will get. Now suppose if I want the one number, right, one should be right shift by 2 times, okay. So what will happen? So 0 times is like this is again, first when we will write the, we will write the same number, like write the number that will be the 0 times, okay. Now we have to move 1 times, so this one will come out, right. So here will be 0, here 0 0, and again another 0 will come. This is the 1 times, okay. Now for the second time, what happened? Again in the, for the second times, this 0 will out, okay. Now 0 0 0 0. So if nothing is there, then the result will become 0 0, okay. So this is the how you can, the concept is like that, you don't never confuse, like it always remember data and number of times. This sequence will be the same for the left shift and the right shift. So in the left shift and right shift, the questions is like the, during the interview, technical interview for the embedded system engineer, embedded software engineer, they ask that, okay. So yeah, like divisible by 2, same divisible by 4, okay, or they will ask multiplication, okay, by 2 or 4. So basically, okay, so first of all I am going to write the one, you know, the binary sequence, how we write the binary sequence. Okay, so for that what we do first, we have to 4-bit binary sequence. I am going to write 2 raised to power 0, 2 raised to 1, 2 raised to 2, 2 raised to power 3. So I am not going to write the big data, okay, for this binary number. I am going to use the very total, like if we are having 0, 1, 2, 3, 4, 5. Okay, so now if we now see here is the 2 raised to power 0, means it is showing that 0 and 1. So if 2 raised to power 0, it means 1. Okay, so you have to write 0 and 1 in one interval, right? One alternative you can say. So 0, 1, 0, 1, 0, 1. So now suppose that 2 raised to power 1. So 2 raised to power 1 is equal to 1 is equal to 2. So what we have to write? We have to write in this way: 2 raised to power 1. So 0 will appear 2 times, 1 will appear 2 times, again 0 will appear 2 times. In this way the sequence will go on. 2 raised to power 2, 4. So 0 will come 4 times and 1 will again come 4 times, like the sequence will go. Let go for the other number, like 2 raised to power 3. So the number will 8 times 0 will come, 0, 0, 5, 6, like that, 7, 8 it will go. Okay, so now see the what is the role of the left shift, and let's see the purpose of making this table. See, if you shift 1 by left shift by 1 time, okay, then what happened? It the become 2. If you shift 2 to 1 time, so this one will come here, okay, this one will come here, so the result will become 4. So meaning that if you shift by 1 in left side, then number will divide by number will multiply by 2. Okay, in the same way, suppose this is the 2, and if you shift, okay, it is a, this is suppose it 2. If you shift by right shift by 1 time, then what happen? It will divide by you can say 2. Okay, so like that actually it happens. And the now we have covered third and fourth. Now we have to cover the AND operation. Third and fourth we have to mention here, and now we have to use the AND operation. So basically, in AND what we do, like suppose we are having the AND, okay, so AND operator is this one. Basically we define. So what is the truth table like? Okay, so result truth table for this is like suppose 3 and then move to 4. Okay, so suppose 0, 1, 2, 3. Sorry. Yeah, it's fine. If you want, you can write in this way also. So now 0, 0, 0, 1, 1, 0, 1, 1. So now AND operation, it and the 2 bits. Okay, so 0, 0, 0, 0, 1 and is 0, 1, 0, 0, 1, 1 is 1. So now see the how the AND operation is work. So AND operation basically we use for the masking purpose. Also we use many places. Okay, um, masking purpose, right? And if we count the problem, like if we want to know the number of ones in a number, okay, those questions where we can solve it from the AND operators. In the same way, if we are having the like sixth is the NOT operator. Okay, So basically, what not operator does, basically we are having the not operator. So basically, not operator is like what it does. Suppose your number is having, you are having 1. Okay, so if you are in the 4 bit, if you are representing the number 001, if we do the not operation, if we do on that not operation, okay, so not operation if we do, so what happens, it will become 110. Okay, so meaning that 0 will become, it will completely change the value, like 0 to 1, right, 1 to 0, like this. Suppose in the second case, suppose take the example, another example, like you are having the 0011. So basically it represents the 3. Okay, so if I want to do the not operation on that, so if I will do the not operation, then result will become 1100. So basically what not operation does, what the not operation does basically, if you want the truth table, is it takes one input, right, and it change the bit, right. If it is 0, if the x is 0, it will make 1. If it is 1, it will make 0. Okay, so this is the use of the not operator. So guys, please let me know if you have any doubt regarding this, the concept truth table. Basically in this video I have discussed very basic concept of the XOR or XOR, left shift, right shift, and operators, and the not operators. So in the next video, I will cover the compilation stages, and in that I will cover this one, that why, how the bitwise operator is going to optimize the our code, why in the embedded system we prefer the bitwise operators. These are the questions, right, I will cover. And please let me know if you want to cover the interview questions also. If you want to cover in the in the tutorial, I will cover the some interview questions, and I will try to give the solution. Right, definitely these questions, if you are going for the embedded software engineer or the for the Linux device driver in development, these questions is going to ask. Okay, so and if you like the concept, if you like the way I described, then please like and subscribe my channel, and yeah, keep in touch. Thank you very much.